All right, so complex numbers. Well, let's just start with something that's not complex at all. Um, Square root of 25. So square root of 25 is uh, either 5, that's the principal root, or it could be negative 5, right? Because negative 5 times negative 5 would be positive 25. Therefore, the square root of 25 could be negative 5. Um, right? Uh, okay, but what do we do with this? The square root of negative 25. Is it possible to square a number and get a negative number? Negative 5 times negative 5, as we just saw, is still positive 25, right? So it seems like there would be no square root of negative 25 because there's no number that you can square to get negative 25. Um, well, a number was invented or discovered, depending on your philosophy of math, which resolves this issue. So we go like this: the square root of negative 25, we could say, is equivalent to the square root of 25 times the square root of negative 1, right? So 25 times negative 1 is negative 25. The square root of 25 is 5 or negative 5. We'll go with the principal root. And then the square root of negative 1 is I. So this is altogether 5I. Um, I stands for imaginary, and it was called that basically out of ridicule because it was considered that this whole concept was sort of delusional. Um, the concept has been around for a while. Heron of Alexandria, who lived about 2,000 years ago, is considered the first to have observed this unit, this quantity called I. Now, it wasn't called I then, but this idea of a square root of a negative of negative 1. All right, so yeah, that's what I stands for. So I is the square root of negative 1. Or actually, the technical definition of I is that I squared is negative 1. So therefore, I is the square root of negative 1. Okay, so we've invented this number or discovered it, and so now that allows us to take the square roots of negative numbers, which is apparently very useful in engineering problems and also physics. Um, Apparently, imaginary numbers are really good for modeling variables that are two-dimensional instead of one-dimensional. That's about all I know about that. So if you want to look into that, look into that. Sounds pretty interesting to me. I'll be looking into that. But you probably won't see a lesson about it. Okay, so 5i is an imaginary number. It's a real number multiplied by this strange quantity or unit called I. Um, so a complex number is the sum of a real number and an imaginary number. So 3 plus the imaginary number 5i. This altogether would count as a complex number. It's the sum of a real number, or 3 minus 5i. These are complex numbers. So that's what they are, and actually, they behave very much like your normal binomials. Um, like 3 plus 5x or 3 minus 5x. The only difference is x can stand for anything, whereas I stands for one very specific thing, square root of negative 1. Um, so, but keep in mind, it's like these binomials. So, for example, we can add them just like adding a binomial. So we've got the complex number 3 plus 4i, and we want to add it to the complex number 2 minus 5i. So we can add like terms. 3 plus 2 is 5. And then 4i and negative 5i are like terms. Alright, so 4i plus negative 5i is just negative 1i, or just negative I. Alright, so we've just added two complex numbers, and we get a complex number, 5 minus I. We can subtract complex numbers, and I stacked them on top of each other. It's easier to keep track of what are the like terms, what are you allowed to subtract and what are you not. So 2 minus 1 is 1. 2 minus 2i minus 6i is negative 4i. Sorry, let me move that negative over. Okay. So yeah, we just subtracted two complex numbers and we get a complex number here. And you can even multiply complex numbers, and it would work just like you would expect if these were just binomials. If it were, x instead of I, with one exception, we know exactly what I stands for. So we just use FOIL. We could FOIL this. So 1 times 2 is 2. Just switch colors here. 1 times 3i is just 3i, so plus 3i. 5i times 2 is 10i. 5i times 3i is 15i squared. 5i times 3i is 15i squared. Well, we know exactly what I squared means. That means negative 1. So this is 15. Okay, which is negative 15. We can combine like terms here. 3i plus 10i is 13i. Okay, now 2 and negative 15 are like terms. So 2 plus negative 15 is negative 13. Negative 13 plus 13i. That. So we get a complex number here. So it behaves as you might expect, if I were just a normal variable, so that these were binomials. But it's not just a normal variable. It's not a variable. It has a specific constant value. So I is the value of, it's defined as I squared is negative 1, which means that I is the square root of negative 1. So that's what I always stands for, the square root of negative 1. Other than that, they just add and subtract and multiply, not entirely unlike things that you're used to. All right, good luck with complex numbers.